All right, welcome to the deep dive. Today, we're going to be looking at something that's really, at the core of managing any network, and that's Windows Server security and authentication.
Yeah, it's mission critical.
Exactly. You've shared a huge collection of articles with us, and it's like having the blueprints for Fort Knox, but for servers. We're going to try to break it all down and give you the essential understanding of how Windows Server basically keeps things locked down.
Right. I mean, we have articles that are detailing everything from authentication policies to, Kerberos configuration, credential processes, device health attestation, public key authentication for domain-joined devices, GDPR, the implications of GDPR, guarded fabrics and shielded VMs, also config security tools, password storage and policies, protected users, secured core servers, security support providers, the system key utility, TLS SSL protocols, Windows authentication architectures, and concepts, Logon scenarios, WinLogon's automatic restart sign-on.
Wow, that's a mouthful.
It's a lot.
Yeah, it's a real deep dive. So let's jump into it. Oh, absolutely.
One of the foundational things, I think, is how Windows Server determines who can access what.
Yeah.
The articles talk a lot about authentication policies and silos.
Right.
Could you kind of explain that a little bit?
Well, the way to think about authentication policies and silos is that they're a mechanism by which you can create, granular security zones within your network.
Okay.
Right. And so the idea there is that by being able to segment your network and control the lifespan of things like Kerberos TGTs, which are, digital access passes, you can really limit the impact if an attacker were to compromise an account.
Got it.
And so authentication policies, at their core, define the rules for, how long these digital passes last and what conditions need to be met for access, by different types of accounts.
Yep.
And they're built on, authentication policy silos, which are, essentially containers within Active Directory where you group users or services that have, specific security needs. So it's kind of like having different departments in a building under different security protocols. Like some areas you need a key card, some you need a biometric scan. Is that kind of the same idea?
Precisely. That is a great analogy. So, these policies are essentially controlling vital aspects. For instance, they can, dictate the lifetime of a Kerberos TGT, how long that digital pass is good for. They can also set access control conditions.
Okay.
So you can define things like which computers a user can log in from or which services a particular account can authenticate to.
So it's pretty granular.
It can be. It can be very granular.
So how do you actually set these policies up? I mean, is it all command line stuff?
Not exclusively. You have options. The articles mention that you can use the Active Directory Administrative Console, which provides, kind of a graphical way to manage these settings.
Okay.
But you can also use PowerShell, which is, for those who prefer scripting and automation. You can use PowerShell CM delets to configure both policies and silos. And there's this interesting concept where you can actually apply a policy directly to a single account without placing it in a silo.
Huh.
And that could be useful for, like a very sensitive administrative account.
Right. So you don't even want to associate that with any other group.
Right. You want that totally isolated.
Just completely on its own.
Exactly.
Interesting. Now, what are the underlying elements in Active Directory that make all this possible? Like, what's going on under the hood?
Right. So this is where you get into, specific attributes that are tied to, users, computers, and services within the Active Directory schema.
Okay.
Right. And so, for example, there's an object specifically for authentication policy.
Uh-huh.
And then there's a container called authentication policies.
Okay.
And then, crucially, there's an attribute called authentication policy enforced.
Okay.
And this essentially acts as the on-off switch for a policy. And so when it's not enforced, the policy runs in what's called audit mode.
And audit mode is basically just kind of observing, like, what would happen if it was active, but it's not actually preventing anything.
Exactly. So in audit mode, the system is recording potential successes and failures related to the policy.
Right.
But it's not actually blocking any actions that violate it.
Got it.
And so this is valuable because it allows you to test the waters.
Right.
Right. You can see what the impact of the policy would be before you actually, fully implement it.
Right.
And so once you're confident, then you flip the switch to enforced mode.
Right.
And that's when the protections actually kick in.
So it's like a dress rehearsal for your security protocols.
Precisely, yeah.
All right, so how do these policies actually get linked to, actual users and computers?
Right. So this is through attributes like assigned authentication policy,
Okay.
right? And so that links, a user, computer, or service account to a specific authentication policy. And then for users, specifically, there's user authentication policy and its related backlink, and then similar attributes exist for computers and services.
Got it.
Right. Um, and then there are, more specific attributes like, MSDS user allowed to authenticate from, which dictates, which computers a user can log in from.
Mm-hmm.
MSDS user allowed to authenticate to controls which services they can authenticate to.
Right.
And then, of course, user TGT lifetime defines, how long those Kerberos tickets remain valid.
So those are all attributes within AD.
That's right, within Active Directory.
Okay, cool. Now you mentioned silos earlier. How does being a member of a silo actually contribute to this access control?
Right. So when you link an account to an authentication policy silo, it essentially adds a claim
Okay.
to that account. So imagine, every user or service has this, kind of digital identity card.
Mm-hmm.
And when you link them to a silo, it's like adding a special stamp on that ID card. That marks their membership in this specific security group with its own, set of rules.
Got it.
And that claim then becomes a factor when access decisions are being made.
Okay, so they have the silo membership stamp. How does that actually then restrict what they can do?
Right. So this is where the Kerberos protocol comes in.
Okay.
So when a user attempts to access a service, their Kerberos ticket, granting ticket, and that initial, kind of entry pass
Right.
is presented. And if an authentication policy is enforced on that service account, the domain controller, examines the TGT's privilege attribute certificate, or PAC-O.
Yeah.
And the PAC contains information about the user's identity,
Okay.
including those silo membership claims.
Got it.
And then the domain controller uses the access control conditions that are defined in the authentication policy to decide whether to issue a service ticket.
Okay.
And so if the user's TGT and its claims don't match the policy requirements, then the domain controller will deny that request.
Got it. So it's like a two-step verification. First, you get the general access pass, the TGT. And then when you try to use that for a specific resource,
Right.
your silo membership is checked against that resources policy.
Exactly.
Cool. Now, shifting gears a little bit, the articles mention some improvements to Kerberos itself.
Right.
What are some of the things that have been enhanced?
So starting with Windows 10 version 1507 and Windows Server 2016, Kerberos clients, gain the ability to support both IPv4 and IPv6 addresses, host names and service principal names, or SPNs.
Okay.
Right.
And those are the SPN. Those are just unique identifiers for services on the network.
That's right.
So why is supporting IP addresses in that significant?
So by default, Windows won't even try to use Kerberos if the host name that it's trying to reach is just an IP address.
Okay.
It'll fall back to other authentication methods like NTLM.
Okay.
And so there are situations where applications are hard coded to use IP addresses,
Right.
instead of host names. And so in those scenarios, if you're trying to, kind of enhance your security posture, and you've disabled weaker protocols like NTLM, this automatic fallback can cause compatibility issues.
Got it. So by having the IP address in the SPN, you're basically telling Windows, yes, even for this IP address, use the strong Kerberos authentication and forcing those legacy applications to use that.
Exactly. That's a great way to put it.
Okay, cool.
And so the recommendation is to use the setspn.exe tool to register these IP addresses to the appropriate service counts in Active Directory.
Okay.
But you have to keep in mind that, an SPN can only be associated with one account at a time.
Right.
And so if you are registering IP addresses, it's best practice to ensure that those IP addresses have, static leases.
Right. You don't want the IP to change and suddenly your SPN's pointing to a different server.
Exactly.
Good point.
Yeah.
Another Kerberos-related term that came up is constrained delegation.
Right. That sounds very, very limited.
It is, but in a good way, right?
Okay.
So Kerberos constrained delegation is a more secure form of, traditional delegation.
Okay.
And traditional delegation allowed a server to act on behalf of a user to any other service within the domain.
Okay.
Constrained delegation tightens that up significantly.
Okay.
It allows you to specify exactly which services a particular server is allowed to act on behalf of a user to.
So you're putting, strict boundaries on what a delegated service can do.
Exactly. Yeah.
Okay.
And so in earlier versions of Windows, configuring constrained delegation required domain administrator privileges.
Okay.
And it was limited to services within the same Active Directory domain.
Okay.
And so this created challenges in, larger and more complex environments.
Right.
Where, for example, you might have a front-end service in one domain that needs to access, a back-end service in another domain. Right. You don't want a web server in one domain having unrestricted access to, like, a sensitive database in another domain.
Exactly.
Okay.
So to address this, the Windows Server 2012 and later introduced what's called resource-based constrained delegation.
Okay.
And this is a big security enhancement.
Okay.
And it allows you to configure delegation on the account of the resource service itself.
Okay.
Rather than on the delegating service.
Yeah, okay.
So what this means is that the administrator of that resource service gets to decide, which front-end services they trust to impersonate users when accessing their resource.
Okay.
And importantly, this works across domain boundaries.
Okay.
Using an extension to the Kerberos protocol called S4U2 proxy.
Okay.
And essentially this shifts the trust decision from the delegating service to the owner of the resource.
Right. So instead of the front-end domain admin saying, hey, this server can delegate to anything, the back-end domain admin gets to say, this specific front-end server is authorized to access my resource.
Exactly. Yeah.
That's a much more secure and logical model.
Exactly.
Okay.
And then lastly, with Kerberos, it's important to note that for accounts that are members of the protected user security group, Kerberos will refuse to use the older and weaker DES or RC4 encryption types during the pre-authentication process.
Okay.
And so what this means is that your domain environment needs to be configured to support at least AES, in terms of encryption standards for those protected accounts.
Got it. Now, speaking of keeping credentials safe, these articles delve into how Windows actually handles and protects those.
Right.
It sounds like a pretty, complicated process just to log in.
It is. It is. It's a lot more, going on under the hood than most people realize.
Yeah, for sure.
So for interactive logins, when you actually sit down at the computer, you've got winlogin.exe, right, which is the process that handles the secure user interaction.
Okay.
And then it passes the credentials that you provide, the username, password,
right,
to the local security authority or LSA, through a library called secure32.dll.
Okay.
And then for non-interactive logins, like when a service starts up, you'll often see a kernel mode component called casesedd.signed involved there.
So WinLogin is like the security guard at the login screen?
That's a good way to think about it. Okay. Yeah. And secure32.dl is kind of like a gateway to the different authentication methods that are available.
Okay.
And then you have lsessorrv.dll, which is the local security authority service.
Okay.
And this is a key component. It not only enforces security policies, but it also manages the different security packages that are available on the system.
Okay.
And it even includes, the negotiate function, which can intelligently decide whether to use NTLM or Kerberos, based on, what the capabilities of the client and server are.
So it's kind of figuring out the strongest common authentication language.
Precisely.
Okay.
And underlying all of this is the Security Support Provider Interface, or SSPI.
Okay.
And this is really the fundamental architecture for Windows authentication. Okay. And it's Microsoft's implementation of the, kind of industry standard generic security service API or GSS API.
Okay.
And so, within this SSPI framework, you have security support providers or SSPs, which are, the actual DLLs, the files that implement specific authentication protocols.
So the SSPI is like the overall framework, and the SSPs are like plugins that handle the specific authentication methods.
Exactly.
Okay.
And so Windows comes with a set of default SSPs.
We've got Negotiate, which helps choose the best option.
Right.
There's Kerberos itself,
Yeah.
and TLM for backward compatibility.
Okay.
Channel, which handles the secure web protocols, TLS-SSL. There's Digest. Cred SSP, which is for secure credential delegation, important for things like remote desktop.
Okay.
And PKU2U, which is related to online identity integration.
Okay.
And so when a client and server need to authenticate, they go through this negotiation process, to find an SSP and therefore an authentication protocol that they both support.
Got it. Now, what happens when you log into like your domain?
Right.
Or where are those credentials stored?
Yeah.
At least temporarily.
Right. So each time you log on to a domain, Windows caches those credentials, right? It stores them securely in the registry.
Okay.
And this is what allows you to log on to a domain joined machine, even if it can't reach a domain control.
Right. Because it uses that locally stored information.
So it's convenient for, like, when the network's down or whatever, but it sounds like it could be a security risk if that cache were to be compromised.
Well, it's always a balance, between usability and security.
Right. Okay.
And so then there's also this feature called automatic restart sign-on, or RRSO, that was introduced in Windows 8.1. And so if a Windows update requires a restart, RSO allows the last interactive user to be automatically logged back in. So the LSA saves the user's credentials in encrypted form, specifically for this purpose.
Got it.
And then, once the system restarts, the user is automatically signed in. And then the session is immediately locked. Right, to protect it.
So the machine automatically logs you back in after the update, but then it locks things down immediately.
Exactly.
And
there's even a group policy setting that you can use to control or disable this behavior if you want.
Got it. Okay. So lastly here, the articles talk about the role of digital certificates in Windows authentication.
Right.
Can you kind of, unpack that a little bit?
So digital certificates, provide this mechanism for verifying the authenticity of users and devices.
Right.
And so a public key infrastructure, or PKI, provides the framework for issuing and managing these digital IDs.
Got it.
And so, when you use a certificate for authentication, the data is processed using cryptographic hash algorithms, things like SHA-1, to create a unique digital summary called a message digest. And this digest is then digitally signed using the sender's private key, right, which acts as a proof of authenticity.
Right.
And then the receiver can then verify that signature using the sender's corresponding public key.
So it's like a digital passport that can be cryptographically verified.
Precisely.
Okay.
Yeah.
Now, you mentioned protected users earlier, and it sounds like that's a specific security group that has some extra safeguards built in.
Right. So the protected users security group is designed to provide enhanced security protections for accounts that are members of it.
Okay.
Right.
Okay.
And so when you add an account to this group, it triggers a set of non-configurable security restrictions.
Non-configurable. So that's pretty strict.
It's pretty locked down.
Okay.
Yeah. And these apply on both the client devices and the domain controllers.
Got it.
Provided they're running supported versions of Windows.
Right.
And so for members of this group, several older or less secure authentication methods are disabled.
Okay.
They can't authenticate using NTLM, Digest Authentication, or Cred SSP, default credential delegation.
Okay.
Kerberos will refuse to use the weaker DES or RC4 encryption types, during the pre-authentication phase.
Okay.
They can't be delegated, using either constrained or unconstrained Kerberos delegation.
Got it.
And the default lifespan of their Kerberos TGT is limited to just 4 hours.
Okay.
So they have to re-authenticate more frequently.
Right. So it's forcing the use of, more modern and secure authentication protocols.
Exactly.
Okay.
Now, it's important to note that you shouldn't add service accounts or computer accounts to the protected users group.
Okay.
Because doing so, won't actually provide any additional local protection, because the password or the certificate for these types of accounts is always available on the host itself.
Okay.
Right. And then if you're troubleshooting any issues related to protected users, there are some new event logs that are available in the event viewer. You've got protected user client log and protected user failures domain controller log.
Okay.
And these are disabled by default, so you'd have to enable them if you want to, monitor and diagnose any related events.
Got it. Okay, cool. Now let's talk about device health attestation, or DHA.
Right.
It sounds like it's basically a way to like confirm that a device is trustworthy.
Yeah, that's exactly right. The purpose of DHA is to assess the overall health and integrity of a device.
Okay.
And it does this by verifying the measurements reported by the device's trusted platform module, or TPM,
Okay.
and the platform configuration registers, or PCRs.
Got it.
And so these logs basically provide a tamper-proof record of the device's boot process and its configuration.
Okay, so it's like a digital bill of health for the device.
In a way, yes.
Okay, cool. Now, how is the DHA service deployed?
Right. So Microsoft offers the DHA service through a few different, deployment models.
Okay.
There's the DHA Cloud service, which is managed by Microsoft and is, generally available.
Okay.
Then there's the DHA on-premises service, which is a server role that you can install on your own Windows Server 2016 or later infrastructure. And then there's the DHA Azure Cloud service,
Okay.
which is basically the on-premises service hosted within Azure.
Got it. So what are the advantages and disadvantages of each? Like, why would someone choose one over the other?
Right. So the DHA Cloud service offers convenience, right?
Mm-hmm.
It's managed by Microsoft. It's globally accessible.
Okay.
The DHA on-premises service gives you more control,
Okay.
right? And it's particularly appealing to organizations that already have, Windows Server 2016 or newer licenses.
Why?
Because it's included without additional cost.
Okay.
And then, it can also be beneficial for environments that have, strict regulatory compliance requirements.
Right.
Or maybe they don't have reliable internet connectivity.
All right.
Right. And then the Azure Cloud Service basically combines the control of on-premises with, the scalability and the infrastructure of Azure.
Got it. So if you've got the on-premises infrastructure, that option seems like a good way to maintain control.
Yeah, definitely.
Okay. Now, what are the basic, requirements to get DHA on-premises set up?
Okay. So the key prerequisites for DHA on-premises, first you need a server running Windows Server 2016 or later.
Right.
You need Windows 10 or later clients that have, a TPM chip, either version 1.2 or 2.0.
Okay.
And that's been, initialized and is ready for use.
Right.
You'll also need to decide whether you want to use EK-cert or AK-cert validation mode for the TPM.
Okay.
And then you'll need to obtain a few specific X.509 digital certificates.
Okay.
So you need a DHA SSL certificate to secure communication with the DHA server.
Got it.
You need a DHA signing certificate to digitally sign attestation data.
Okay.
And then you need a DHA encryption certificate to encrypt sensitive information.
So there's a bit of certificate management involved?
There is, yeah.
What's the actual process of installing the DHA server role?
Okay. So you would typically start by, installing Windows Server 2016 or later.
Uh-huh.
Ideally with the desktop experience for easier configuration.
Okay.
And then you add the device health attestation server role using the Server Manager console.
Okay.
And after that, you install the signing and encryption certificates.
Okay.
You can do this through PowerShell.
Got it.
You'll also need to install a package containing the trusted TPM root certificates.
Okay.
And this usually needs to be downloaded from Microsoft.
Okay.
And you might need to customize it to remove any root certificates that your organization doesn't trust.
Okay.
Once it's customized, you install it by running a provided setup script.
Okay.
And then you configure the DHA service itself using PowerShell.
Okay.
And you configure the certificate chain validation policy.
So it's a multi-step process, but definitely manageable.
Yeah, definitely.
Okay. Now, what about devices that are joined to a domain?
Right.
The articles talk about public key authentication for them.
Right. So this is another technique to enhance security.
Okay.
And so if you have a domain controller running Windows Server 2016 or later, when a domain joined Windows device starts up,
Okay.
it will automatically check if a public key had already been provisioned for its computer account in AD.
Okay.
And if not, it will generate a bound public key
Okay.
and configure it for its account.
Okay.
Now, if all of your domain controllers are running older versions of Windows Server, then this automatic key provisioning won't happen.
Okay.
And so you would have to manually configure it.
Got it. So how do you actually enforce the use of these public keys for authenticating domain joined devices?
So there's a specific group policy setting called support for device authentication using certificate.
Okay.
And if you configure that setting to force,
Yeah.
then the device will require, a Windows Server 2016 or later domain controller to be available
Got it.
because it will rely on that provisioned public key.